Parametric equations, that's brand new, you haven't done it. Eliminating the parameter, that sounds super fancy, it really doesn't. And then, of course, we're going to do some equations here in a second. So, first off, couple things here. What are parametric equations? They kind of look like a system of equations to me. You'll have two of them, an x equals and a y equals, of course, and we can use them to describe any curve. So, think of the curve, here's where it's going to get fun, as a path of a point moving in the plane. So we can all graph. We all know how to graph things, okay? But the new thing you're going to have to see, not that it's a big deal today, we're also going to be showing the direction of the curve. So you're going to be seeing me mark some arrows on the graph indicating how the point would be moving along the graph. Not a big deal, but I just have to show you that. Because your x and y coordinates of the point are functions of time. So as your time is increasing, what is the graph doing? That is what we are looking at today. So these two specifically are an example of parametric equations. It's like I said, it kind of makes me think of a system, so to speak, and they give you these specific values. So we are going to sketch the graph of it. So just to get it started, I'm going to throw some x and y axes over here. Okay. And now notice too, and sometimes they give you some constraints. This little -2 less than or equal to t less than or equal to 2. Sometimes they do not. It just depends on the problem. So what I'm going to do is we can graph anything, of course, with our t-chart. Now, our t's, you can see, are going from -2 to +2. So I'm going to start at -2. That's all I'm going to do for that. Now, when we graph, though, of course, we want our coordinates x and y. So next I'm going to figure out the x coordinates. So I'm going to add a column. So I'm looking at my x equation. I'm just going to mental math it. I'm going to put -2 in here for t. -2 plus 2. -1 plus 2. 0 plus 2. 1 plus 2. 2 plus 2. A little mental math. Very exciting stuff, I'm aware. And of course we need y. So I'm going to add another column. Now, we are plugging the values for t now into our y equation. So I'm going to do -2 squared,
4.
-1 squared, 0 squared, 1 squared, 2 squared. Okay. Now, when we plot points, I need to put, I'm looking at my numbers here, and I'm like, well, we go up to 4. It's nothing too crazy. They're all positive. So I'm going to just throw a few tick marks on here. Just enough to kind of cover it. And remember, when we plot our points, I'm going to talk about the t part in a second. Your plotting points is still the same as it's always been. You are plotting your x comma y's. So I'm just looking at the right two columns. So I'm going to plot 0, 4, 1, 1, 2, 0, so on and so forth. So 0, 4, 1, 1, 2, 0, 3, 1, 4, 4. So we see it makes a parabola. Got it? All right. Now, last thing I'm going to mark on this. This is the new and exciting part, and I say that sarcastically, obviously. So, because we can all make t-charts, we can all graph stuff, okay? So, parametric equations, remember the key is, or what it talks about in the definition, it's the path of a point moving along. So as you start with our -2, our first point was 0, 4, then it went to 1, 1, 2, 0, 3, 1, 4, 4. So I'm going to mark the direction the point would be moving. So if you start at 0, 4, and then I move to 1, 1, 2, 0, 3, 1, 4, 4, we are moving in this path. So I'm just marking arrows showing the direction that we move. Isn't that exciting?
That's all?
That's all. I got a couple new twists for you on the back. It'll get a little more challenging. Not a lot more challenging, but a little. So you do have to, and you will see, of course, directions on your test. You'll see it in the review packet. It'll be a specific reminder. Make sure you mark the direction of the path. That's what I'm referencing on those green arrows. All right, let's do another one. So just some different equations. I don't know what's happening back there. I'm going to set up my axes. Oh, I'm already being bullied. Now, it tells you, of course, t is greater than or equal to 0, so my t column, I'm going to start with 1. or 0 I mean, and we'll do, I can't remember, did I do x in blue I think on the last one? Now as I'm looking at the t, it's not as specific, it's just anything greater than or equal to 0, but I'm like, ugh, I gotta square root t. So I'm gonna be a little smart here on the values I pick. Like I'm gonna pick 1 because I can square root 1, it comes out pretty nice. We know my artistic skills. I don't know if I want to square root 2. I don't know if I want to square root 3. I'm going to go to 4. And again, we don't have an ending limitation on our values for t, so I'm not going to get carried away, but let's throw one more in here. What would be one more good number? You could do 16.
Oh.
But I'd probably go a little smaller. Because I don't want to have to mark out like a bazillion tick marks if I don't have to, right? All right, so let's put in the values for t into our x equation. Square root of 0, square root of 1, square root of 4, square root of 9. And of course, I need to add a column for my y's. Okay, so remember, you're plugging the t into the y equation. 3 times 0 plus 1. 3 times 1 plus 1. 3 times 4, this one's making me nervous. I think it's going to be off the graph. I don't know. What's 3 times 4 plus 1? I'm going to graph that one. What's 3 times 9 plus 1? Okay. So, am I going to do the 13 and the 28? No promises, right? Now, x and y, remember when we're looking at the points, I'm looking at these guys. I don't know if I'm doing the 13.
We don't have to graph all of them.
We just are looking for the path. Now, marking out to 28, I don't want to mark out to 28. Okay, so let's plot the 0, 1. I'm going to do 1, 4. And I don't know about you, that's kind of a good enough gist. I can tell you the path that this would be moving. Can you?
It's going to go up.
Yes. So let's connect these. I'm just going to arrow it off. Now, I'm going to keep it consistent today. The new exciting part of our parametric equations, we want to mark the path that the point would be moving. Well, if we start here at 0, 1 and go to 1, 4, just like Avery said, we're moving up. So I'm just going to throw some arrows on to indicate the path that we are moving. There it is. Okay, questions on that guy? All right, pretty easy stuff. That's like the front side of your homework. Again, depending on the problem is how many points you need. This one, super specific, -2 to 2. I kind of like that one a little better. This one, you just needed greater than or equal to 0, and you can see some of them quickly got off of my graph grid. Okay, last thing I'm going to show you that we're going to spend a little time on here, how to eliminate the parameter. Meaning, you want to get it out of parametric equations and get it into an x and y equation, a y equal. So we could maybe graph it in our calculator or head or whatever. So, you want to represent it, of course, by a single rectangular equation, x, y. And here it kind of gives you the gist on how to do it. So, again, I don't know why, this is just my mind works, I guess. Seeing those two equations, I always think of it as like a system of equations. And clearly it says we're going to kind of basically solve it by substitution. So anytime I teach substitution, whether it's Algebra 1 or this class, I'm like, start with what you think is the easiest equation. I think the top one's the easiest equation because you don't have squared. I'm going to solve the top one for t, just like it says. I'm going to substitute it into the bottom one. So I'm going to solve this top for t. I'm going to add the 4. And then, of course, we're going to divide everything by 2. So options, how you want to write that. You can leave it x plus 4 over 2. You can make it 1/2 x plus 2. I don't care. I'm just going to roll with it. And I'm going to substitute this into my other equation. Now, here's where it might be kind of algebraic. So I've got the 4. I have to square that. That gets the groan. Now I say this kind of gets the groan because when you do x plus 4 squared, you would have to FOIL it out. I don't know if I want to FOIL it out because again, okay, work smarter, not harder. I'm thinking about the graph. I'm like, well, you know, I think I'm going to leave it x plus 4 squared because I'm thinking already that's going to be in an equation of a parabola. And I think I could probably get it graphed pretty easy without having to FOIL it. I am going to kind of write this a little prettier though. So I'm just going to leave the x plus 4 squared. I'm not going to FOIL it, I'm just going to leave it. I'm going to square the bottom, 2 squared. I'm like, oh, nice. What happens to the 4s?
Cancel that.
Bam. So here is my rectangular equation. Sketch the graph. I can sketch the graph of that all day. That's the parent function of the parabola shifted 4 units to the
Right. Left.
left.
I don't know my left and right.
It's okay. It's okay.
I'm being so free.
Oh, yeah.
So you can see I'm not getting crazy on the points here, of course. We're not getting crazy on the points. So it would be shifted to the left. So our standard, remember, parabola, we're going to have our vertex here at -4. And then I'm just going to maybe left 1, right 1. And then I'm not even going to put another point. I'm going to be out of room. Okay. Now, the other thing, the new, it's not exciting. I'm going to quit saying exciting because it's not, is we have to mark the direction of the path. Now, notice I don't have the crazy T-chart with the T, the X, and the Y. Can I make a crazy T-chart with it? Do I need to? What would be the direction of the path?
Wait.
Maybe you're wrong.
Oh wait, that's what I meant.
That's how I'm asking.
Oh yeah. No, I got it. I was thinking
So you can still do your T-chart, do your whole, like if you just put 0 in and go through and maybe like 1, you can easily see the path of it, or I think we could mentally figure the path of that, okay? So, some of the directions I think get a little crazy. It says eliminate the parameter. So they want you to get the T out and solve it in X and Y only. So it is a graph that's something we can easily just sketch. That's the goal. So I threw this one on for Alfonso. You may not think it. We thought it should do some cos and sine in there. That's why I said this is where you might want your unit circle for it. Okay, so same deal. We're going to solve one of the equations for T, and then I'm going to substitute it into the other. Well, I'm just going to start on the top one. I'm kind of like, okay, if I want to try to get T alone, well, let's subtract 3 off. And then I'm going to divide by 2. So I'm going to have x minus 3 over 2 right now. I've got cos of t. Now, here we go. This is going to be a fun one. I like this one. Normally, I would say, I don't have t alone. I'm like, I'm going to get rid of cos and then cos inverse. I'm like, oh my gosh, this is going to be a mess. Sit tight on that one. I'm going to get fancy. I'm going to kind of do the same thing on the bottom equation. I'm going to get sine of t alone. So I'm going to add the 1. And I'm going to divide off the 2. And right now you're like, we really haven't done anything. It seems like we're working in a circle. Now, we do have a fun-filled identity I can use. Identities back from chapter 7.
Oh wait.
Yellow sheets, never getting rid of them, that involve sine and cosine.
Tangent.
We could make tangent. I don't feel great about that because wouldn't that be a fraction nightmare though?
Okay, never mind.
What's sine squared plus cosine
1.
squared? So I'm going to use that little fun-filled identity. This is what I'm working off, and you'll see why in a sec. So I'm going to replace, of course, sine is this crazy-looking fraction. Cos is the blue one. Because remember, our goal is to get it into an equation with just x and y and without the crazy t's. Did I do that?
Yeah.
Yes. Is it a little messy? Yeah. I'm thinking, well, what's the graph of this look like? I'm going to try to simplify it a little bit more. So I'm going to square both of these. I'm not going to FOIL. We're going to be over 4. Again, I'm not going to get crazy and FOIL it. 2 squared 4. Now, I would cancel out the fractions. To get rid of the over 4, just times everything by 4, right? And this is just me. I like the variables in alphabetical order. So I'm going to flip-flop that left side. I'm going to put the x first. So I'm going to times everything by 4. And we can handle it. I'm going to put the x first. So I'm just going to rearrange here. 1 times 4, 4. So there's my equation, which we should recognize from geometry is an equation of a circle. Remember my dramatic hint? I said it seems like we're working in a circle. Okay, all right, so we can draw a circle. What's the center? Got it. Radius. All right, let's start marking it out. Notice I gave you a small circle. Mrs. Reynolds would be so proud. So there's my center. Oh, I think I need a couple more points to the right to fit it all on here.
Good enough.
All right. Up 2, down 2, and with Avery, good enough. Okay, now we need to mark the path we would be traveling. So it is a, thank you for that, Kale. But which direction, clockwise or counterclockwise?
Clockwise. I don't know.
We're 50-50, it's a 50-50. Now, if you're do old school, make your little table. I'm not going to put a million numbers in here.
No. It's
Now,
clockwise.
No, Avery.
It's gotta be clockwise.
now again, like I said, I'm not going to get crazy and put a bunch of numbers in. I'm just going to try to get a few in so I can see the path. Now, if I put 0 in here, here's where I said you might, or maybe you just know it at this point, need to look at your unit circle. What's the cos of 0? Cos of 0 times 2 plus 3. Okay? I'm going to go ahead and put 0 in this guy too. Sine of 0. 0 times 2, 0, negative. Okay, so 5, negative 1. That's kind of where we're starting. I'm not marking the path. I'm just pointing out that's where I'm
It's gotta be
starting.
clockwise.
Let's throw another point in here. Now, again, I'm thinking about, because you have cos and sine in there, I want to pick values not like 2, 3, 4, 5. I'm going to use, let's say, pi over 2. I'm going to use 90 degrees.
Oh.
Use your chart. What's cos of pi over 2? 0 times 2, 0 plus 3. Okay, put it in this guy. What's the sine?
No.
Oh boy. What's the sine of pi over 2? Times 2 plus
It's
that.
clockwise.
So we go from 5, negative 1 to 3, 1. So it's counterclockwise. I'm going to mark it blue. I don't care how many things you put on, but just show it's counterclockwise.
Are they all counterclockwise?
I'm not necessarily.
So yeah.
No, I didn't say that. Jeez Louise. Okay, so the other reason too I picked the pi over 2 is this. You're between 0 and 2 pi. So I'm thinking about the circle. You know, if I needed another point, I would have used pi for t. If I needed another, I would have used 3 pi over 2. Again, it's just however many points you need to see the path. Usually 2 points does the job, okay? All right, let's do another one similar to this. So same thing, I got the sine and cosine. This is a little different graph, so don't think you know what I'm doing here. All right, I'm going to solve the top one. I'm going to divide by 3. And then same thing on the second equation, I'm going to divide off the 4. Now remember our goal, we want to get the t's out of there. We want just x and y so I can graph it. So again, I'm going to use the exact same identity, sine squared plus cosine squared equals 1. Let's see what we can do with that. So sine squared y over 4 squared plus x over 3 squared equals 1. Now I'm going to square out everything, of course. Y squared is 4 squared. I'm going to make it 16. X squared over 3 squared. I got rid of the t, so that's a win. Now again, this is just me being OCD. I like the x first and then the y. I like the alphabetical order. This is not a circle. So we're going to work off this equation. It's circle-ish. Okay, I don't know if that's a technical math word, but it's kind of like a circle. Here's the difference, okay? So in the last one, notice we were over 4, and I multiplied and got rid of the parameter. I'm going to leave the fractions this time because they're not the same number. They're different numbers. This is a graph you have not yet seen in your mathematical careers. We will cover these in more depth coming up in another chapter. But this is an oval. It's an ellipse. So I'm going to show you how to mark it out. So. Now, see if you can catch this. I'm thinking about how many tick marks to put on. Ready? I'm going to do 3 left, 3 right, 4 up, 4 down.
That's right.
All right. Why 3 left, 3 right? Why 4 up, 4 down?
Numbers, not square.
Yes. So you take that, you square root it. That is your horizontal count. You take this, you square root it. That is your vertical count. That's how you graph ellipses. Like I said, we're going to do a whole lot more with ellipses in another chapter. And I'm going to try to draw an oval. It looks like an alien. Okay, we're just going to go with it. We're not going to talk about it. Now, of course, the question is, we have to mark the path. Now, I'm not going to get crazy and do a million points here, but I need my little table. And again, we're between 0 and 2 pi. I'm going to start with 0.
Oh my gosh.
Again, what's the cos of 0? 1 times 3. Sine of 0 times 4. So my starting point is right here. So I'm going to see where it travels to next. Now again, it says to use between 0 and 2 pi, so I need at least one more. And again, if I can't see it, I'll throw pi it. If I still can't see it, I'll do 3 pi over 2, but I think we'll see it after. Okay, what's the cos of 90, or pi over 2?
1.
0 times 3. What is the sine? That's why I said you can use your pink sheets. What is the sine of pi over 2? 1 times 4. So we're going from 3, 0 to 0, 4. Well, I think that's enough for me to mark in the direction, right?
Are they all counterclockwise?
I'm not confirming nor denying that. All right, so any questions on that ellipse? That is a new graph. Nothing too crazy. You can handle it. All right, couple more. So, exponentials. You know I love an exponential. It's been a while since we've done an exponential. Here's the fun part, and I love this one. I need to solve that top equation for t. How are you going to get t out of the exponent?
Put it into log.
Put it into log form. The inverse of an exponential is a logarithm that we covered way back, and I forget which chapter. So, you are a genius. So I'm going to rewrite this. Log. I didn't hear it either. Log base what? 2 of. All right. Just like always, we are going to substitute this in to the other equation. I know.
Now that we're doing it,
So I'm going to replace t with this whole and crazy look, and I'll write it in blue so they match. Log 2 of x.
Oh wait, shoot.
Now, I think I can simplify that a little bit more with my properties of logarithms. Get ready for it. If that was just like a log 2, I'd cancel it, but I've got the negative in the front, so I have to kind of deal with that first. Remember, from all those properties we did, and it's been a while, a negative, any number in front, I don't care what number it's in front, negative 1 in front, is really also an exponent.
Oh my gosh.
what is this?
So that is the same as x to the negative first power. So any number down in front, that's that power property of logarithms. It's been a while. And then, of course, these cancel out. So do I have it down to an equation with x and y that I can try to sketch on the graph?
Yeah.
Sure. If the negative exponent weirds you out, I mean, if some people don't like it, remember this is the same as this. I personally think the fraction one might be a little easier to do. So I'm going to graph off that, but I'm going to kind of circle them both. All right. Okay. Are we ready to graph this guy? Now we got to be a little bit careful of what numbers we put in here for x, meaning you can't use what?
0.
0, because 0 under the line is undefined. And also it's making me a little nervous. I see this little thing over here, this t is greater than or equal to 0. So I am going to make the table like we first started with, just to make sure nothing goes off the rails here. And get it going. Okay, so if we put 0 in, so I'm going to put it in here. 2 to the 0 is what? 2 to the 0.
0. 1. I'm kidding.
What is 2 to the negative 0? 1. So I should probably throw some tick marks on here. I'm going to graph as we go.
So then why did we stop?
Well, just hang on. Just wait for it.
What was the point?
Just wait for it. Okay, let's put another nice easy number in. 2 to the first.
Wait,
I'm going to do the red in a minute, Avery. Okay, put 2 in the y one. What's 2 to the negative second?
1/2.
Close.
1/4.
1/4.
Oh.
Okay, now is that getting pretty tough for me to graph?
That's quite cheeky.
I'm going to try one more number, but that's probably going to be the end of it because I'm worried about this column. Okay, 2 squared. That's easy. 4. That's a messy 4. Put in, of course, a 2 here. 2 to the negatives.
116. No.
1/8. 1/16.
What has happened here?
I said 116.
I think we messed up the table because this should be a half.
Oh!
Oh, wait, did I tell you no?
Yes.
I'm sorry, Owen. I was thinking about the next one. That is my bad. I'm sorry, Owen. I can't believe I just had to say I'm sorry to Owen. Oh my gosh. Oh my. That still looks like a half on my graph. I'm just going to leave it. Owen, I'm sorry. 2 squared. I was thinking about the next one. That's my fault. I was thinking about the next point already. Do I need a 4? I need a 4.
What?
Okay, 1/4. Good enough. So the graph kind of looks like this. Now, okay, and you can mark the direction, yes? We already can mark our direction. Okay, 8. What is this? What is this? What is? Why do you have like 5 pens?
She's been putting them in my. This is more than 5.
Okay, all right. Now, oh my God.
Taking them from this.
All right, let's finish this up, my friend. So 2 things. 1, we can mark the direction. Yes, you've marked the path. Okay, let's mark it. And I'm going to talk about the red. Now, this time, I did kind of ignore the red when I graphed. Here's why. This 1 over x, if you actually, here's a super rough sketch. If you actually graph it, there's this half, and then there's this half on the other side. It's 2 curves. It's a rational expression. Because you could put like -1 in here. -1, -1, so on and so forth. So I was kind of like, oh man, I don't know how much of the graph this is going to be. I don't want to draw this piece if I don't need it. The reason I kind of ignored it on this one and it made me nervous on it and go to the table is because you did have this constraint on it of these specific numbers 0 and up. So I didn't want to have to draw the left side of the graph for nothing. So that's why I'm like, well, work smarter, not harder. And I just went old school to the table so I wasn't drawing any unnecessary pieces. But like I said, if you actually pull up, just to show you a little nicer, oh, I don't have my graphing calculator open, but you will see the other half would be on this side. And I didn't want to have to draw all of that for nothing. Okay. Elliot, did you have a question for me?
It's just that, shouldn't the graph keep going up because isn't the y-axis also in essence
Correct, but remember you've got this, you're starting at 0. So that you got this restriction on your starting point. So my first point I can end up with is the 1, 1.
Oh, you do.
Because of that.
That's true.
That's why I didn't do the full-on drawing from the beginning, because that greater than 0 made me nervous.
Why did
Okay.
you just put numbers greater than 0 in the first place?
Well, but I mean, we had to kind of look at it so you can see it. All right, last thing I have for you. This is easy. Ready? Are you mad at Jackson? Okay. I'm not going to ask any questions.
I didn't do anything.
All right. Oh my gosh, poor Kale. So, converting rectangular, focus people so we can get done with this, please. Converting rectangular to parametric. So, rectangular x and y. Parametric is like the system that has the t in it. Now, this is where you kind of have a little flexibility in how you want to do it. Because, of course, there's more than one way to represent an equation. 2/4, 1/2, 4/6, all the same stuff. We can do it just different things, okay? So my choice, I look at this and I'm trying to kind of deconstruct it in my head. So this always jumps out to me, that 3x. So for mine, how I'm going to roll with it, I'm going to start with this, because I need t in here.
We're just going to add t.
And I'm going to deal with this in a sec. Remember, my final answers, I want an x equals equation and a y equals. I want the system and I want them to have t in it. Well, I can solve that for x pretty easy and pop it down in here for my x equation. I'm not even going to do any work, I'm just going to do it. And I think I can do this one now with t in it.
Wait, what?
So if I solve this for x, I'm going to have t over 3.
Where did we get t from?
It's the opposite of what we were just doing.
Thank you, Alex. Thank
We
you.
just added it.
We were turning t into x and y, now we're turning x and y into t.
Correct.
Yeah, wait.
All right, and then I'm going to replace that with t.
T's nowhere to be found.
You just choose something and make it t.
Now, exactly, Elliot. I've had other kids in the past, and like I said, there's other, different ways to represent the same equation. I've had kids in the past just be like, well, I'm going to just do t equals x. Okay, and then they write it, with that version in it. I mean, okay, so there are different ways to represent your parametric equations. To me, this just seems too similar to the original, so I just kind of avoid that. It seems weird.
To the original. What does that
Yeah.
matter?
They look similar. If you like it, use it.
So you could literally just put in t for x and just put x as t.
That seems kind of pointless, though. Pointless. So I'm going to do the same thing. I'm going to do t equals 2x.
So
And again, I'm just going to put my final answers down here at the bottom. I can solve that for x in my head, t over 2. And then this one, I'm going to write it t minus 8. And I kind of should have spaced that out better. So now I have my system, my parametric equations that have t in them versus x and y in a single equation.
Done.
All right, couple more. What do you want to do t for this one? T equals x squared. Okay, I can roll with that. So this is probably the easy one to write. What's your y equals equation? T plus 3.
you get a whole lot.
What's your x equals?
Square root. I knew it, Avery. I was joking.
Okay.
I'll do the next one right now.
Okay.
We'll decide switch to green for fun. All right, so what are you doing on this one? You're letting t equal, I like it. So the y one's super easy. What's your y equation?
T plus 8. Q root of t.
I won't even. Okay.
We're done.
We're done.
Yay.
Okay. Any questions on that?
12 pencils.